In this video, we will discuss the compound interest formula. Our learning targets for this video are that you will become familiar with the compound interest formula and its derivation, that is, where it came from, how we get the formula. The second learning target is that you will be able to make computations using this formula. Now, first understand what the formula does. The formula is going to relate principal, interest rate, the number of times interest is compounded in a single year, the number of years that the principal will remain untouched, and the ending balance. So all of these variables will be accounted for in the formula. It basically gives us a way to calculate interest without performing all of the tedious calculations that are required when we compound interest using only the simple interest formula. Let's try example number 1. Rico deposits $800 at 3.87% interest compounded quarterly. What is his ending balance after 1 year? To figure this out, I'm going to use the compound interest formula. A equals P times 1 plus R over N to the NT power. In this formula, P stands for principal, R stands for interest rate, N stands for the number of times I'm compounding in a single year, and T stands for time. To solve, I'll replace P with the principal. The principal is $800, so I'm going to replace my P with principal, $800. I'm going to replace R with the interest rate. The interest rate is 3.87%. When I place this into the formula, I actually change it to a decimal value. I'm going to write this as 0.0387. For my value of N, I'm going to replace that with a 4 for quarterly. The word quarterly means 4 times per year. If I'm compounding 4 times per year, that gives me an N value of 4. The letter N, the variable N, is actually used in the formula twice. So I'm also going to replace the N that is in the exponent with a 4. T stands for time in years. My time is 1 year. I'm wanting to find the ending balance after 1 year. So I'm going to replace my T value with a 1. Now, we're very grateful that we have calculators because your calculator will calculate this for you. All you have to do is type it in as it's written. And if you type this in as written, the calculator will return back a value for you of $831.41. Now keep in mind that this is the ending balance after 1 year. This is not the interest. And the ending balance after 1 year is $831.41. What this tells me is that I've actually earned interest of $31.41. And that $31.41 has been tacked on to my $800 to give me that ending balance. Nancy deposits $1,200 into an account that pays 3% interest compounded monthly, and we want to know her ending balance after 1 year. We'll first recognize that if I'm compounding monthly, this gives me an N value of 12 because there are 12 months in a year. I'll set up the formula. A is equal to principal times 1 plus interest rate divided by number of times that I'm compounding in a single year raised to the NT power. I'll replace principal with 1,200, rate with 3% written as a decimal, so that's 0.03, N with 12 because I'm compounding monthly. I'll also replace the second N, the one that's in the exponent, with 12. And since I'm compounding, since I want the ending balance for 1 year, I'll replace the T with a 1. My calculator will do the computation for me. So if you plug all of this into your calculator as written, then the calculator will deliver back the amount that will be her ending balance, and that amount is $1,236.50. Let's try another problem. Maria deposits $1,650 for 3 years at 3%. compounded daily. We would like to know her ending balance. So again, we're going to use the compound interest formula. In this case, the principal is $1,650. My interest rate is 3%, which as a decimal is 0.03. I'm compounding daily. Compounding daily means that I'm compounding 365 times because there is 365 days in a year. So my end value would be 365, and I'll write that in the formula twice. I want to know her ending balance after 3 years. This gives me a t value of 3. So for t, I'm going to put it in as a 3. Again, I use my calculator to perform the calculations for me. The calculator returns back a value of $1,805.38. And so this is the amount of money that will be in her account at the end of 3 years. Let's try example number 4. Kate deposits $2,350 in an account that earns interest at a rate of 3.1% compounded monthly. Because we're compounding monthly, our end value will be 12. Since we want to find our ending balance after 5 years, our t value will be 5. Let's plug it into the formula. We're going to take the principal, multiply it to 1 plus the interest rate divided by the number of times the interest is compounded per year, and raise that to the nt power. Our principal will be $2,350. Our interest rate is 3.1%, or 0.031, written as a decimal. N is 12, which we write twice in the formula, and t is 5. We let the calculator do our calculations for us, and our final balance will be $2,743.45. Keep in mind that this formula is returning to you the ending balance, not the interest earned. If you are ever asked to figure out the interest earned, you could simply do this. Take the amount of money at the ending balance, that is after 5 years, $2,743.45, and subtract the beginning balance, the amount that I started with. The difference in these two will give me the amount of interest that I've earned. And so this account earned $393.45 interest over the course of the 5 years.